So we're space architectures, and this is Tybor, Xander, and Tom. We have a lot to get through, so jump right in. Okay, what inspired us to create this mass timber residential building is the current housing crisis that we're facing, and also the materiality of mass timber, sustainability, aesthetics, as well as the closeness to the Western Canadian culture.
For our project, we've chosen a high-density, low-rise residential zoning for our building within the Ogden community on 24th Street Southeast. Within our immediate vicinity is the nearby Ogden Fire Station number 9 and currently abandoned Canadian Royal Legion 154. The area also has nearby public bus stops and a future planned LRT station to the northeast. With a lot area of 3,000 meters squared and a FAR rating of 4, on this location, our massing evolution included 3 versions, starting as a cascading design, becoming blockier, and finally settling on a final design. We then divided it and organized the building into quadrants, giving us a building area of 1,500 meters square with 7 stories and a gross floor area of 11,500 meters square.
There's about 3 coordination for our project. Our parquet. So our parquet located 4 meters below the surface, below the grade. After facing many challenges, finally we were able to add 66 required parking stalls, including 10 EV charging stations you can see on the yellow box, and 4 accessible units. In the middle, we have total 44 bike lockers. In the middle, also we have 2 utility rooms in the northeast and southeast corner. To access our parquet, we have 7-meter wide ramp and 2 elevators to stairs. Our first floor have a 3 CLU, including a bakery, a cafe, and a bookstore. A loading bay, a garbage room, a manager room, 2 elevators. The main stair is located in the east side. We also have 60 additional bike lockers and a well-equipped gym in the southeast corner. The open wide residential lobby located to the next to our beautiful courtyard. We also have 105 residential mailbox in the main lobby also. Here's our 3 stereo, again, a bakery, a cafe, and a bookstore. Our ramp is again a 7-meter wide ramp. The slope is over 1/7, and the clear height of the ramp is 2.7 meters. At the right side, we have a well-equipped gym for all the residential occupants. Here's our typical floor plan. Our typical floor plan has 12 one-bedroom units, 3 two-bedroom units, and 3 studio units. Total 18 units. We have 104 residential units in the project. One thing I forgot to mention, we have a garbage chute and a utility room in every floor. Here's our 7th floor. It's almost the same floor plan as our typical floor. Except we have a big rooftop patio instead of 3 two-bedroom units. And you can see our utility room in the middle, including a garbage chute. Our one-bedroom unit size 61 to 67 square meters. They all are identically the same. We have total 72 units in the project. Our two-bedroom unit size is 63 to 82 square meters. We have 1 smaller unit and 2 larger units. Total, we have 15 two-bedroom units. Our studio units are 40 to 48 square meters. Again, we have 1 smaller unit and 2 larger studio units in the project, and total 17 units. Here's our 3D design for our kitchen and our toilet. Our toilet has a plumbing shaft for our plumbing pipes and the utility pipes.
Now, let's talk about systems. Our project uses 4 main exterior systems, the first of which is our exterior cladding, which we source 3 products from Northern due to their reliability, versatility, and affordability. They consist of aluminum composite standard panels, aluminum composite cassette panels, and finally wood composite fluted panels. Next, we've chosen the Conyers 1600 UT System 2 curtain wall for our glazing due to its high thermal performance and general reliability. We've chosen their 1 3/4 inch triple pane infill option along with insulated thermal pockets, giving us a possible U value of around 0.15 to 0.45. For our roofing systems, we've chosen 2 different designs from Zinco. Firstly, we've chosen their stormwater management roof to improve our water retention amount up to 55 liters per square meter retention capacity. Additionally, this roof allows us to comply with Calgary's water retention strategy introduced in 2023, as well as cooling our building's microclimate by up to 45 degrees Celsius. As for the second of the 2, we've chosen their lightweight pedestal system for our patio, giving it adjustable versatility and accommodation for hidden pipes or wires. Lastly, our building includes a standard solar array system located on the roof, of which the panel mounting systems are also provided by Zinco. With our design, we have around 1,270 meters squared of roof area. Of that area, we want to know how much of that can be allocated to our new solar array. Using a solar study, we concluded that the minimum spacing between panels would be 120 millimeters, giving the panels 100% efficiency during the summer and 45% efficiency during the winter. Our proposed array covers 79% of our roof area, whilst keeping utility spaces in mind. Our panels have a surface area of 0.82 meters squared per panel, of which 1,037 units were proposed, giving us a total panel area of around 1,007 meters squared, which produces us a 160,000 kilowatt hour per year output. Comparing that to the 582,000 kilowatt hour per year usage average of a residential building of this size, we would then be able to cover 27.63% of our total power usage.
All right, for structure calculation of our mass timber elements, we use FASTAP introduced to us by our industrializer MAR. It takes parameters such as grid spacing and building height and spits out structural elements and their respective sizes. As we integrate these structures into our design, we encounter a significant challenge in the building code, section 3.2, building fire safety. Our building falls between 2 articles, 3.2.2.51 and 3.2.2.48. With Article 51 permits combustible materials, our building's height of 30 meters and 7 stories exceeds the limit of 18 meters and 6 stories indicated by the code. Through consultation with our instructor, we've identified potential solutions. We can create a concrete podium and start the mass timber structure from the 2nd floor up, effectively treating the 6-story residential portion as an independent combustible structure on top of 1-story non-combustible building, thus complying with Article 51. However, a key goal of our project is to create a positive impact on the community and reflect the Western Canadian culture through the mass timber. Therefore, we have to expose them, and especially in the CRU and lobby areas. So we moved on to Article 48. It has a less stringent requirement on the heights and number of stories. It also allows for mass timber construction, which is encapsulated. After many talks with our instructors, industry advisors, and various guest speakers throughout the semester, we mustered the courage to push the boundary and seek alternate solutions based on Article 48 and 51. And here's 2 major points of our proposed solutions. Number 1, adding an additional 2-hour sacrificial layer on the exposed mass timber structures based on the very conservative charring rate of 0.8 millimeters per minute, which equates to a thickness of 96 millimeters per exposed face. Number 2, use intumescent paint on all exposed mass timbers. The product we chose is FX Lumber Guard XE from Fire Retardant Coating of Texas. It works for engineered wood, which is mass timber, and has Canadian certification as well. Most importantly, it's a clear color paint and showcases the mass timber exposed. And it will cost about $24,000 for our project. And the planter in the courtyard. So like any inexperienced AT students would do, we create a topple solid and subdivide a portion of it, change the material to grass, and slap the biggest tree we can find and wrap in there. However, our industry advisor immediately told us that the parquet is just 300 millimeters below. You have no room for roots. To address this, he suggested to build a dirt mound on top of it to increase some space for roots. But the dirt mound is still not enough for the size of the tree we want to plant in there. So we went a step further by designing a planter that extends downward another meter, which gave us a total depth of 1.3 meters for the planters, for roots. That is enough for a 7 to 10 meter hopper tree in there. Then structurally, we incorporate this concrete planter through a network of concrete beams and transfer beams, tying them into our existing grid while leaving just enough space for the parking and back storage. That's all.
Thank you, everyone.